10.7a, polar coordinates and graphs. So when we have a rectangular ordered pair, we're in the form of x comma y, right? For a rectangular ordered pair, x comma y, right? Now for a polar ordered pair or a polar coordinate, it's known as r comma theta. All right. So r comma theta is your polar pair. Okay, I know it's not really called a polar pair in mathematics, but I like to call them polar pairs because it sounds fun. All right, they're really called polar coordinates as in r comma theta, where r is your radius, that's how far away from the center it goes, and theta, think of your unit circle, that's the where it's going. Okay, so that's the directed angle that it has. So, for instance, we have a couple up here. If I have 2 comma pi over 3, if I have 2 comma pi over 3, I get to the angle where pi over 3 is. All right? And then I go out 2. So that's why we have 2 comma pi over 3 right there. Does that make sense? All right? So on this one, I have 3 comma negative 11 or negative pi over 6. So negative pi over 6 is the same thing as what? 11 pi over 6. And then I go out 3. And so my polar pair is my r comma theta. Now, this one's actually wrong. The book did this one wrong. This should actually be 3 comma 11 pi over 6. All right, so you go 11 pi over 6, and then you go out 3. All right, so that's how polar pairs work. All right, so if you understand your unit circle, this is just an addition. Instead of 1, it only going out 1 all the time. Now we're going out a different amount. All right, so let's look at this one. 3 comma 5 pi over 4. All right, so on this I have to find where 5 pi over 4 is located. So 5 pi over 4 is located in the what quadrant? The third quadrant right here. And then I need to go out 3. And so 3 comma 5 pi over 4 is right here. All right. Now, this next one I have is 4 comma 5 pi over 2. Is 5 pi over 2 actually on the unit circle? No. So what do we have to do? We have to subtract 2 pi. We have to get to its coterminal. So I actually want to think of this one as 4 comma what? Just pi over 2. If I subtract 2 pi, that's really 4 pi over 2. So now I have 4 comma pi over 2. So I find my pi over 2, and then I go up 4. So 1, 2, 3, 4. So that's where that one is. Does that make sense? Oh, there it is. All right, let's look at this next one. Now I have negative 3 for my radius at 11 pi over 6. Well, 11 pi over 6 is right here. All right. However, what kind of radius do I have going on now? I have a negative radius. So guess what I need to do? I need to go backwards. All right. So now I need to go backwards 3. And so this one would actually end up being right there. All right. So we actually need to go backwards, and so it would end up right there. Now, how else could you name this negative 3, 11 pi over 6 one? How else could you name it? 3 comma what? 5 pi over 6. That means the same thing. All right? It's just a different way to Tampa. All right? So, I would like you to name this ordered pair, or this polar pair, 3 different ways. All right? I'd like you to name that polar pair 3 different ways. What we got? You give me one.
I know 2 pi over 3.
2 comma what?
Pi over 3.
Not pi over 3.
4 pi over 3.
4 pi over 3. I'll take that one. All right. Cooper, what's another one?
Negative 2 pi over 3.
Good. I'll take that one. All right. So you go pi over 3 and then you go back 2. That's fine. All right, Jacob, give me another one. Skipper.
2 negative 2 pi over 3.
Good. 2 comma negative 2 pi over 3. So he went backwards with his angle. All right. All of those are at that green polar pair. All right. Pretty good. Now I'd like you to draw out this triangle. Have I'd like you to draw out this triangle, and then we're going to talk about it a little bit. All right, so you have an x, then you have a y, you have a theta, and then you have your hypotenuse being your r, your radius. Okay? So this is very similar to our unit circle. We're just going to go a little bit further. But if you understand your unit circle, this is not hard at all. On our unit circle, our radius was always what? 1. It was a unit. All right? Now, our radius is not always going to be 1. Right? How did I want you to think of sine? Sine was y, right? So sine is still going to be y, but it's going to be over r because it's the opposite over hypotenuse. All right? And then how did I want you to think of cosine? X. So cosine is still x, but now it's x over r. Okay? Because it's not over 1 anymore, it's over something different. It could be 1 still, but it's not always going to be 1. So this is how these are thought of. How do you think of tangent still? Y over x. So it all goes back to that unit circle or this triangle necessarily. All right? So then, when I need to go from polars to rectangular, I a lot of the times use these, but I don't want you to think that they're just made up. How did I get x equals r cosine theta? Because cosine theta equals what? X over r. And what happened? You just multiplied by r. All right? So x is equal to r cosine. So y is equal to r sine. And all it was this, just multiplied over. All right, so I don't want you to think that they're just these arbitrary, weird formulas. And then if we need to go to rectangular to polars, you guys already know these. Tangent theta is equal to y over x. All right? And then, what is this r squared equals x squared plus y squared thing? That's Pythag. All right? So it all goes back to that triangle. Your x squared plus your y squared is equal to your r squared. All right? So those are the 4 formulas that we're going to be using today and throughout these polars. All right? We got them down? All right, we're moving. So here we go. Polar to rectangular. So we're going to go from a polar pair, r comma theta, and I want my rectangular pair, x comma y. All right, so I'm going from r comma theta, and I need to go to x comma y. All right, so I'm going to show it algebraically, and I'm going to show you how to do it graphically a little bit. All right, so how do I get to x? X equals what? R cosine theta. All right, and then y would equal r sine theta. Well, what is my r? 2. And then I have cosine of pi. Well, what is cosine of pi? -1. And so now I have 2 times -1, which is -2. And then I have my r is 2, and then I have sine of pi. Well, what's sine of pi? 0. So 0 times 2 is 0. So my ordered pair is -2 comma 0 for my rectangular coordinates. Now, let's think about what this did. If I have 2 comma pi as my my polar pair, as my polar coordinate, where's pi at? It's left, right? It's the x-axis. And how far out did we go? We went out how many? 2. So it's right there. Guess what we did? That's the same thing as what? -2 comma 0. All right, so that one you really didn't even have to do any math. All right, let's do B. So on B, I have r comma theta is square root 3 comma pi over 6. Well, I need to get to x and y. You know what? Let's graph this first. I actually want you to graph it first. I wanted to prove it on the other one. But let's graph this first. What quadrant are we in? Where's pi over 6 and then a positive radius? We're in the first quadrant. So we're somewhere over here. All right? Somewhere over there. All right. So what should my x value be? Should it be positive or negative? Positive. What should my y value be? Positive or negative? Both should be positive. All right. So make sure we do that when we get our answers. So how do I get to x? X equals what? Square root 3 times cosine of pi over 6. And then y would equal square root 3 times sine of pi over 6. Well, what is the cosine of pi over 6? Square root 3 over 2. And so now I have square root 3 times square root 3 over 2, which is just what? 3 over 2. And then what's my y value? So what's sine of pi over 6? 1/2. So now I have square root 3 times 1/2, which is square root 3 over 2. All right. So my ordered pair is 3/2, comma, square root 3 over 2. All right. And so that would be my rectangular coordinate. All right, let's do this next one. So I actually want to do part B first, and I want to show you just on the sketch. So now we're going to go from a rectangular x comma y to a polar r comma theta. All right. So let's sketch this to just kind of make sense of it. What is 0, comma 2 doing? It's just going up 2. I want to show you that you can do this one without doing any math at all. If I just go up 2, what would be my polar pair if I just went up 2? What would be my theta? Pi over 2. And what would be my radius? 2. I'm done. There's my polar pair. All right. Now, I want to prove it with our formulas as well. Okay, I want to prove it with our formulas as well. So let's do our theta first. And so the one thing that has theta in it is this tangent theta equals y over x, right? So I'd have tangent theta is equal to what? What is my y? 2 over 0. Well, 2 over 0 is undefined, true? So when is tangent undefined? It actually happens twice. At pi over 2 and at 3 pi over 2. However, what's going to be my answer that I want? Pi over 2. Why?
Goes up instead of down.
Because it goes up instead of down. All right? And that's where I tell you to draw a sketch just to make sure you're getting the right one. All right? And then I want to solve for my r. All right? I already know what it's going to be, the answer to it, but let's just do it with algebraically. So the other thing I have is r squared is equal to x squared plus y squared. So I have an x and a y, and now I need to get to my r. So I have r squared is equal to, what's my x? 0 squared plus 2 squared. And so I'm not going to keep going with it. What's my r? R equals 2. All right. And so my polar pair is 2 comma pi over 2. All right. All right, let's look at this next one. It will never say the second quadrant. It will just give you a ordered pair and then go from it there. All right, so I have the rectangular pair of -1, 1. I always like drawing a sketch because I think it helps you think about it a little bit. So where's -1, 1? It's in the second quadrant. All right, it's right there, right there. All right, and so let's solve for our r first this time. So I'd use r squared is equal to -1 quantity squared plus 1 squared. So r squared is equal to 2. So r is equal to square root 2. And then I need to get to a theta. I have my r. I need to get to my theta now. So what formula do I use? Tangent theta is equal to my y over x. So now I have 1 over -1. Or tangent theta is equal to -1. Wow, that's really laggy. All right. So when is tangent -1? At what? No. At 3 pi over 4. And when else? And at 7 pi over 4. But which one do I want? I want 3 pi over 4. Why? Because it's the second quadrant. All right. So my polar pair is going to be square root 2 comma 3 pi over 4. Okay. If you gave me square root 2 7 pi over 4, I'd give you some credit, but I'm not giving you full credit. You know what I'm saying? Because it's actually wrong. Okay. All right. So just draw a little picture. It's going to help you out. Now we're going to take these polars and we're going to convert them into rectangulars. And I'm going to show you how they kind of match up. All right. So my polar equation is r equals 2. The only information I know about it is my radius is equal to 2. That's it. What do polars usually have in it? It usually has a radius and a what? A theta, an angle measure. All right. Do I have any angle measure? No. Which one you want? Can it be pi over 6? Sure. So I got 2 comma pi over 6, right? Could it be pi over 3? Why not? How about pi over 2? Sure. How about any angle that I ever want?
Yes.
What would it be? It would be a circle. All right. If I just have my radius equals 2, it's a what? It's a circle. Now, what equation do we know that has an r in it? What equation on your little all four of them, has an r in it? What?
R squared equals x squared.
There it is. So r squared is equal to x squared plus y squared. Well, what's my r? 2. So now I'd end up with 2 squared, which is 4. So now I have 4 is equal to x squared plus y squared. Or a lot of the times we think of it as x squared plus y squared is equal to 4. What kind of equation is x squared plus y squared equals 4? It's a circle. It's a circle. And where's the circle centered at? 0, 0, with a radius of
2.
2. All right? So these two things actually are the same. All right? It's just whatever method you're looking at it. All right, let's look at this next one. I get theta equals pi over 3. So this is my polar. And now I need to go to a rectangular. But I want to just graph it first. Do I have a radius for it? No. So what could it be? It could be anything. It could be anything, right? So it could be 1. It could be 2. It could be 3. Why not? How about negatives? Could it be a negative radius? Yeah. So guess what it makes? It makes a line. It makes a line just like so. All right. Now, what equation do you guys know that has just a theta in it? A theta in it with a y over x, or a y and an x. I just said it. Tangent theta. All right, so we're going to use this tangent theta is equal y over x. Well, what's my theta? Pi over 3. So now I need to know the tangent of pi over 3, and that's going to be equal to y over x. Well, what is tangent of pi over 3? Square root 3. Just square root 3. All right, because square root 3 over 2 over 1/2. All right, so we get square root 3 is equal to y over x. Well, normally a line isn't written like that. What would we probably do? Multiply by x. So now we have y is equal to square root 3 times x. So if I have theta equals pi over 3, what is the slope of it? Square root 3. Because this is in y equals mx plus b form. Because where's it going through? 0, 0. All right. You see how they kind of match together?
Yeah.
All right. All right, let's look at another one. So now we have r equals secant theta. Yo, home dog, I don't have secant theta anywhere on my sheets. What is secant theta? 1 over cosine. So now I have r is equal to 1 over cosine theta.
Wait.
I can't convert anything yet.
What?
What's one of the 4 things that might look like something? What? And r squared? I could square it. I don't know if that's the path I want to go. X equals r cosine theta, doesn't it? Well, how do I get to an r cosine theta? I multiply by cosine. So now I end up with r cosine theta is equal to 1.
So x has to equal 1.
So x equals 1. So r secant theta is actually just a vertical line of x equals 1. All right, so that would be my graph on my polar coordinates. All right, pretty nifty?
Yes.
All
Wait.
right. All right. Page 781, those problems. I know it looks like quite a lot. They go quite fast.